acting safety engineer for the Department of Transportation in Montana. And today I'll be talking about the SIMS program, which is our Safety Information Management System. We refer to it as SIMS, and it's the use of safety analysts to complete our HSIP program. There it goes. Montana is a Vision Zero state. We've been for quite a while. Back in 2007, we set a goal of cutting our fatalities and serious injuries in half by the year 2030. We're slowly making progress on that. We've kind of had a few up and down years the last couple of years. However, we would like to keep moving that direction, and SIMS is proving to help us move in that direction. Why the change in system? What kind of precipitated this whole change for us was the Montana Highway Patrol decided to upgrade their system. They went with CTS America SmartCop. That was implemented in 2008. Initially, we tried to convert the data between our existing Oracle system and their new SmartCop. There were a lot of conversions that had to be done in the meantime. It was not real compatible with the Mars system as well. So at that point, we did a business case. We spent a couple years on that. What came out of that was that we wanted to look for a commercial off-the-shelf product. We put an RFP out. We had 3 vendors that were shortlisted to interviews, and SIMS came out, or safety analysts came out on top for that RFP. What we were mainly looking for was a new database and data store, as well as a safety analyst program that would help us improve our system and keep moving it forward in the future. So with SIMS, we do have that new database and new data store. We have a daily, it's a nightly interface with the Montana Highway Patrol's crash data. It downloads each night. It also has a very easy upfront user interface, and that went live in 2014, which was a very quick turnaround. Within 9 months of signing the contract, we had an up and running product, and actually within prior 2 months of that, we were actually starting to use it before it was finalized and accepted by our DOT. My main part of the presentation will be kind of how we utilize it into our HSIP program, both in the network screening as well as other attributes it has that help us. First looking at it, to kind of give you a sense of our network screening, this is straight out of the Chapter 4 of the Highway Safety Manual as far as the how to develop your network screening. For our 2015 list, and I'll take you through our 2015 list, a 2015 site that we took all the way from being identified to actually being nominated as a project. We looked at roadway departure crashes. In Montana, that's one of our major issues. We're a rural state. In the earlier presentation, we're referred to sometimes as a frontier state, where 46 of our 56 counties are actually called frontier counties because there's only 6 people per square mile. So our population bases they're either in the urban areas or they're very scattered across the state. So we wanted to focus on the roadway departure crashes. We also had some SPFs, some safety performance functions that had been developed for Montana specifically. Those have been developed by another consultant for us. We wanted to integrate those in the network screening. We also wanted to look at a level of safety of 4. I'll explain that a little bit further on the next slide, which is the level of safety that has the most potential for being mitigated. We did a sliding window of a mile long. It moved at 1/10 of a mile as it went through our roadway system. And after doing all that, we had 5 or more crashes then that were defined that had to have happened in a 10-year period. Now, in our interstate system, that's very easy to achieve. However, on our secondary roads, which are a lot of our interconnecting roads that don't have a lot of funding to improve those, that 5 or more crashes is difficult to achieve. However, those places do need improvements. So that was why the low number of crashes for a 10-year period. We did come up with 540 locations. That was both on our system, MDT maintained routes, as well as county and city routes as well. And there might have been 1 or 2 Forest Service roads that are heavily used that fell within that as well. For our SPFs, the safety performance functions, They're statistical models used to estimate the average crash frequency for a specific site based on both traffic volumes and roadway segment length. These were specifically made for our state based off data that we had. The area that we wanted to most focus our energy on was the, sorry about that. The area on was level of service 4, which is the location where we have the highest potential for crash reduction. This is if you look at this is basically a parabolic curve. The dark blue line in the middle would be the top of the curve and be the mean, and the 80th percentile and the 20th percentile would be the other two lines. So, excuse me, until I figure out so our intention was to focus on the level of service 4, which then brings us to the network screening within SIMS. This is a snapshot. I'll kind of explain different elements of it as I go along. As you can see in here, we have both our 2015 and 2016. 2015 was the road departure level of service 4. 2016, this year, we actually looked at road departure with nighttime crashes. I won't go into that in detail, but that is kind of how we utilized it for this year's list, which we are still processing. On the 2015 list, in the upper table, we have the primary routes. This is Corridor 1. And down here in the second supplementary table is all of those sites on Corridor 1 as it's sliding across and doing the mile and comparing it to our SPFs and determining which sites meet the criteria. I will get the laser figured out here in a second. My apologies. Okay. As far as our GIS mapping and display, the GIS mapping has been an incredible tool for us, both in our analysis part as well as just a standalone GIS Explorer where we can just look at the crashes, and I'll explain that more at the end. However, in this analysis tool, these are the sites that were identified. It's a long list of 540, about only 20 are showing here. This site number, it's called Corridor 14. I will follow this site on through the process. It shows both our accumulated mileage as well as our reference post mileage. In Montana, we have two systems that Agile had to help us integrate both of those in order to utilize the product correctly and to have the correct location showing on the maps. We also have a comment section. That's where we keep all of our notes so that whoever writes a note on that site, anybody can go in and look at that. There's also the mapping tool. And as you can see here, it's a segment of roadway. There are no cities are involved in this, but you do see a county line down there, that kind of that odd-shaped. That dotted line, that's a county line. We can turn on any of our GIS layers. They're tied to MDT's GIS layers, so our urban boundaries, our city boundaries. In this case, the whited out area is the area that's being defined as the cluster. We can show our reference posting. It also shows the type of crashes by the severity, and those are color-coded. The last thing this also allows us to do is attach our Excel file. So after we've gone through the entire process, we can attach our Excel file, which contains all of our other information that we can't put in SIMS as part of the program. Next, we have the additional diagnostic tools, and this allows our staff to focus on the trends. On the prior page, it noted that there was a rollover, overturning type pattern. We had two methods that we were using that year, one that had been developed by another consultant for us, looking at our crashes over a 5-year period, and then this diagnostic tool was looking at a 10-year period. It reinforced that there was an overturning or a rollover pattern that was being seen. Also, it has a group comparison tab that you can look at and compare it to like minded roads, such as interstates, if it's an interstate, or our secondary or primary roadways. As far as our database queries, there's a large comprehensive data base that everything's tied into. We can go and look at that directly. With a filter, we can filter that down by the route, the reference post, if they're non-junction related, if they're intersection related. And within that, we also have a lot of tables. We have a crash table that are mainly the crash details. We have a person data crash table, a vehicle data. We also have the crash images and the crash narratives. And those are each tied to each crash. So in instance, most of the time for the work I'm doing, I'm using the crash data. However, our behavioral folks that are over in the planning department, who they're looking at drinking and driving, texting, those type of things, they may be looking more at the person data and looking at ages, as far as male, female, those type of attributes, and those tables would be more useful for them. The narrative is probably one of our most valuable uses. You can't tell a lot from just the crash details or the codes that the Highway Patrol is putting in. So with the crash narratives, we were able to look at both types of reports that are coming in. We have the pre-Smart Cop crashes that are coming in. Those are just an image of the crash report itself. The Smart Cop ones are actually, you're just getting a paragraph form that the officer has summarized. Right now, we're kind of caught in between there now, giving us a smaller description than they used to, so we may have to figure out another way to get that information. One of the ways that we're looking at is we do get the crash reports when they are finalized from Highway Patrol, and attaching those to that crash record so that we can look at it later to see if some of the contributing factors from that fatal crash might have been, engineering-wise, could have been mitigated. This is the site that I'd mentioned a few slides back. It was out on Corridor 14, which is out in the middle of central Montana. It's a very rural area, and this half mile to, actually this is about a 5-mile segment, was seeing an elevated crash trend. It was a slight curve, but it was the only curve in several miles that people had to traverse. As you can see, there's no shoulders, the steep slopes. The response time for when a crash is called in is huge. You're probably an hour from a small community to this site. So when we have a site like this and it's been identified, it's gone through an office review, we make the recommendation of do we go to the field or not. In this one, we decided that it was worth seeing if there was something out in the field that visually would give us more information. So 2 people from our office go, and 1 goes from the district office. The district we try to involve in all of these sites, as we are a centralized HSIP program. Everything is done out of Helena, and the district supports us, but the decisions are basically made out of Helena rather than by district themselves. So those district people are able to share where they have projects coming along, where we may be able to tie an improvement and get it done faster and more economical. Out of this particular site, we came up with the recommendation of looking at slope flattening and or shoulder widening. Once we're back in the office, we do a cost estimate. We do a fairly rough cost estimate. We try to take in the majority of the variables that might be out there. In the case of the shoulder widening, we're looking at embankment, topsoil, revegetation, the aggregate. I'm sorry, that was for shoulder widening on the left side, and the aggregate and the new asphalt. Our state looks at all of the variables as far as construction costs, preliminary engineering costs, construction engineering costs, the right-of-way, and the utilities as part of our comparison. So we are not just comparing the construction cost, but we're taking into account those other elements. In this particular area, we had a lot of right-of-way. There were no utilities, so those costs were not included. The other element that we have are the countermeasures that are in a particular library. This is really helpful. We have 5 people that are working on these benefit costs. We have out of the 540 sites, 150 of them we will probably go actually visit in the field and compute probably 100 to 125 of those in a benefit cost. So 5 people are doing those tasks, and as a result, you have a lot of inconsistencies under our old system. So by having a countermeasure library that's very easy to use, it imports the service life on the particular item that we pick, such as guardrail is 15 years, so that when someone's doing the quality control, they're looking for particular items, but they don't have to constantly be checking something that's fairly straightforward like this. And we upgrade that on a yearly basis as needed. If we feel that something in the main crash modification factor clearinghouse has changed, then we'll upgrade accordingly. Once we have all that information, we enter it into the analytical tool. And what's nice down here is this imports the site for us, and so it has the reference posts, it has the number of crashes, whether they're fatals, incaps, incapacitating crashes, capacitating, non-incapacitating property damage, or possible injury. However, once we read through the narratives, we find that maybe only 25% of those crashes are really addressable by the mitigation measure. So we're able to go in and override those crashes and put in only the ones that are addressable, and then do the computation. In this case, we had the shoulder widening, had a lower BC than the slope flattening. Based on our funding, the decision was made to go with the slope flattening as the improvement, and that was then nominated through our standard system, through our Transportation Commission. And then there's a tracking tool in SIMS, which we're just starting to use. It has, we've entered in 2014 crash data, projects. 2015, we're just starting into 2016. So we haven't gotten a lot in there yet, and our traffic design engineer at some point, he will start using this to track the projects. However, currently we're still kind of on an old system of Excel that works well, but we would like to get it into SIMS. Another element that's very beneficial of this is the discarded projects. Whenever we have the list of projects we want to nominate, we send them out to the districts if they made the cutoff of our financial cutoff or minimum benefit cost of 1. However, sometimes you have a project that may be not nominated for a particular reason by the district, and they recommend that we not move forward due to other issues. We would like a record of why those projects have not gone forward. And so as we're trying to move more to electronic tracking and electronic, all of our information being electronic, we need some way that in 3 years, someone new can come in and ask why we didn't move that project forward. So the discarded projects, they go into a separate table and they stay there, and we can reference them at any time. To kind of give you a sense of what we came from, this is our Oracle system. It was a very, it was a good system as far as the results we got from it, but it was not very user-friendly. It had a lot of coding, as you can see down in the one box there. In order to define roadway departure crashes in a rural situation, which you would think would be a very straightforward request you're asking of your data. And we had to go through a massive coding. You had to have it correctly spaced. I'm sure with many of you know in coding there's not a lot of flexibility if you don't have it correct. And so if a new employee came in and was learning this coding and they got results back, you didn't always know if you were getting all the results, the correct results, or if there just weren't any crashes at those locations. So that has really helped as far as new employees and training and getting people up and running and feeling confident with the data that you're getting out of it. The old system also would export things into PDF form. We couldn't use the data to create graphs or figures. If we did, we had to do that manually. So with the new SIM system, the querying is quite easy. We're able to do a lot with the data once we filter it down. The queries are fairly easy. You just go through a filter process. You either add stuff in or add stuff out. You can see easily what you've restricted to the query. Excuse me. In addition, one of the benefits is that you can develop reports of things that you continually want to pull from the data. So if we constantly have the same questions coming from our legal department or from our administration, we can pull the same report time and time again. And we're hoping that as we bring the city and counties on board, we're hoping by the end of this fall to have them have access to their data, that we'll be able to generate some of these reports so that they can easily get to it and not have to go through the filtering process themselves. Even though it's straightforward, when you don't use something that often, it's hard to continually train people with that. This is the tool that I've found the most beneficial, and I've gotten a lot of comments from our staff that how useful it is for them, is the GIS Explorer. It allows us to look at the data from a visual or a mapping sense. When we get a phone call from a citizen or a district, and we can zoom right in on that intersection or that 2-mile segment of road and see if there is a problem. A lot of times we get a call from a citizen of a perceived problem. However, once we look at the data, there really isn't a problem there. And this helps the district traffic engineers filter out some of these problems before sending them to us to go through a full review on them. And so then they're only sending us the ones that there truly could be a problem on. Our rail staff particularly likes this tool. They're able to zero in just where the railroad crossing is and not have to go and look up all of the reference posting and make sure that they have the exact milepost of where they're pulling data from. It also allows us to have any of our layers on that we have at MDT, the urban boundaries, the county boundaries, all of those type of boundaries, our reservations. And when we do put a box on that, where I have there with the red box, the crashes will all come up in a table form, and we can utilize it there. We can also export that data if we need to. The only thing that we don't have from this view is the narrative, and I hope at some point that we might be able to. I don't know if the software is allowed or has the capability of doing that, but that's one comment we've gotten from other traffic staff, is if they could get the narratives at that point instead of having to go back into the comprehensive data and get it that way. So that's one thing that we'll look for in the future. Other things that we're beginning to do are evaluate the fundamental data elements. In this particular case, we're able to look at the roadway departure crashes versus our shoulder width and integrate that with our ADT. This particular graph we're using for our ongoing discussions on shoulder and centerline rumble strips, helping make those decisions. Other data that's available to us now is the Montana Highway Patrol's citation data. We can look as far as seatbelt violation, impairment, those type of things. Our safety group doesn't particularly use those. However, our traffic engineers do use that for their speed studies in looking at if there's been citations and those type of things. And as we continue to move forward, one of our big things is the ongoing training of our own staff. We all picked this up fairly easily. It was a little bit of a challenge kind of changing from our old system to our new system. However, the results have been equal, if not much better what we're getting on the output side, and it's been a much easier process in between. So we want to continue to train our own safety people as well as more of our traffic personnel so that they can use it for traffic operations and speed studies and those type of things. Also, our district traffic engineers have found this very useful. A couple of them kind of prefer to stick with the old way of doing things, which is having our office look at stuff. However, a couple of them have really embraced this technology. They've dove into it, asked lots of questions, and as a result, the information they can give their district and their district administrator has been huge. So it's good to see people are taking on that challenge. We also are trying to provide access to SIMs for local governments. Our cities and counties right now, we're in contractual negotiations with those governments. Some of them have been signed, and we hopefully will have most of those finalized by the end of the year. Our plan is to allow them access to their own data within their boundaries, and versus now we just send them a hard piece of data on a disk, and they do with it within the confidentiality clause that they are required to stay within. We also would like to integrate Fish, Wildlife, and Parks and have Federal Highway have access to it at some point as well. And then we'll continue to evaluate and implement additional data sources as time goes by, as far as what could be enhanced to help our process. So. And with that, I kind of just wrap it up. It's been a great product for us. It's been a big change, but it's one that's our group has embraced very well, and it's been we've had really good results as a result of it. So with that, I'd be happy to answer any questions. We can, but we have to do more of a clip and take it into like an Excel file, but we don't actually store. Are you talking like where we had the road and the crashes were on it? Is that?
You had the image, but I was wondering if on the line item you actually could store
not. I don't think we can store an image. However, we can attach an image, or we can attach an Excel file, and that's what the rest of the stuff that we don't do in SIMS, we put into an Excel file with tabs. And then once we're done with that site at the end of the year, we clip that and attach it into that site. So down the road, people can see all the other background information, the photographs, our cost estimates. But as far as the actual shot, I don't believe it'll fall in that comments section.
Any other questions?
Yes, I have a question. You mentioned the data that comes from the Montana Highway Patrol and that they had changed from a kind of a manual system to this new automated system, and you had problems getting the data over. Can you elaborate what those problems were?
I might ask Shelley if she happens to know what those problems were.
It was just a very complicated data interface that Sheffield did a wonderful job of developing for us. It was complicated because there were so many transformations and so many validations, and the data was somewhat dirty. There was bad data, and we have to validate for the bad data and spit out the bad data, and a lot of transformations. If this and this equal this, this and this, then we want you to put this into this field.
Okay.
Stuff like that. It was complicated.
Any other questions?
Question. I did want to repeat the question because I think we're recording it. You mentioned the local agencies, and that's pretty exciting for us. As Stuart pointed out, we'd like to try to help in any way we can to bring the value to other places. Is there any, what do you see as the primary challenges working with local agencies, and do you see anything that we can do to help support you better?
I would say the challenges are a lot of it is we don't even know who the staff are, and so there aren't with a few of the larger cities we have a personal relationship with, and so there's a lot of relationship building there. I think that's probably one of our biggest things right now is to develop those relationships, because for the most part we're all, just in a building in Helena to them, and vice versa. So I think that one of the challenges is just kind of bringing them together. Our main idea is to give them a training on site where we can help them start to utilize this and hopefully develop that relationship where if they do have a problem or they do want to try something slightly different, that they come to us and keep moving us forward.
I guess just one offer to while we're chatting about it is if you feel like there's reason to support you or to do some kind of a webinar type thing to invite and coordinate that, we have the equipment set up to help support you through the dissemination of that information, inviting the municipalities. I think you have about 19 urban areas or something like that in Montana.
I think it's smaller than that,
Small.
but
Okay.
we have like eight major cities.
Okay.
And then I'm not sure they might classify those as urban. You may know from talking to Craig. I honestly don't know.
I may be cross. I think that's about that in terms of some definition. But my point is that we've got the mechanism to help support you, and it sounds kind of like what New York is doing with some of what they're doing. If there's a way that you can help this local agencies, we're certainly motivated to help support you.
I appreciate that. We'll keep that in mind.
Other questions?
So this hotspot that you mentioned, do you have some sort of index for safety, or is it just pure the crash data that you get the hotspot from?
Just from the crash data, and then comparing it against our SPFs.
So it doesn't matter what functional class is it? Is it interstate or rural or?
The SPFs would be taking that into account. We have ones for just interstate and ones for two-lane roadways. And we
Okay.
don't have a lot of fluctuation in our types of roads, and so in order to keep the data and to get SPFs that they were comfortable with, we didn't split into a lot of different types of SPFs.
And it's based on the number of crashes, or is it the ratio, like the crash versus the traffic on that area?
I would have to get that answer for you. I don't have that on me
okay.
right now.
All right. Thank you.
You're welcome.
Any other questions?
So for the SPF functions, did you have a calibration process? Did you adapt the coefficients to Montana-specific conditions, or?
We hired a separate consultant to develop those SPFs for us. And then as we're running our analysis, we're comparing them against those SPFs. Is that what you're asking? Okay.
Anybody else?
Oh, hi. I would like you to comment on the model inventory road elements data, Meyer Data. I think it's been implemented partially on your system. Do you have plans to implement the full set when they become standard?
I would say once we reach that step, yes.
And how do you use that data now?
As far as I know, we haven't used it a lot. I know we've used it for the shoulder rumble strip discussions. Other than that, I'm not aware of how we've been using it. That was typically done by my predecessor.
Any other questions? Getting my exercise.
You know a lot, and for being a relatively short time in the position, you really got a good command of this.
Been helpful.
So what's been the single biggest benefit of having this system for you?
I would say the consistency, there's 5 of us who work on these benefit costs through the sites all the way through. And I think it's really helped on us being consistent between sites so that from a legal standpoint, if 5 years down the road those sites are called up, it gives a lot of credibility to our program.
Okay. Thank you.
Anyone else? I do have one question myself. Federal Highways recently recognized Montana for your program. Do you want to talk a little bit about what that was?
Sure. That was a combination award that our traffic and safety engineer went out and received. And it was for our roadway departure plan and our SIMS combination of those two processes that we really took our safety program from being a good program to an excellent program, and it's been recognized both internally at our DOT as well as our interactions with other agencies.
Good. Anything else, folks? Okay. Well, Patricia, I want to thank you for presenting to us today, and here's a little token for you for presenting.
Thank you.
Thanks very much.